So dear students, welcome to the lecture 3 on unit 4 about programmable array logic. So what is a programmable array logic? Means which consists of fixed OR gate connections and programmable AND gate connections, so which is completely opposite to the PROM. So these are the programmable AND gates and fixed OR gate connections. So it is a typical architecture of PAL without any connections. So AND gates whose connections are programmable, so that's why it is indicated with a single line, so without any cross marks. Actually the cross marks of fuses has to be kept once based on the truth table. So always do remember, if it is a programmable connection, there would be a single line, and wherever the connections are required, we indicate with a cross marks. And the fixed connections means these are the fixed connections. So there would not be any single line, there would be individual connections like this. So every AND gate output is connected to OR gate with a single line. So there are 3 AND gates, each output is connected to OR gate separately. So this is about difference between fixed connection and programmable connection. So PAL has programmable AND gate connections and the fixed OR gate connections. So this is a typical architecture, and these are the product terms and these are the AND gate inputs. So what are these numbers we'll be discussing later. And you also require direct inputs and complemented inputs. I1 is given directly and I1 is complemented. So you require uncomplemented inputs as well as complemented inputs to design a PAL. And these are the outputs F1, F2, F3 and F4. And one more interesting point about PAL is the outputs can also be used as an inputs to get other outputs such as F2, F3 and F4. This is an important attribute of PAL, where the outputs can also be shared to get the other outputs such as F2, F3 and F4. So in this example, F1 can also act as an input for the other outputs. So this can also be indicated. So later we'll be seeing how this is shared to get the other outputs. So this is the typical architecture of PAL. Now we'll be going through an example, right? If I ask you the question, realize the following functions using PAL. There are 4 functions, W, X, Y, Z, which depends on 4 inputs, A, B, C, D. So these are the 4 letters, which can be represented in the sum of products. So this is a sum of products. I think you know this representation, right? And we'll be discussing if you simplify this sum of products, you'll be getting this. How will we be simplifying? Using K-maps. So that is a different concept. So already you know that. So if I simplify this particular W function, which is given in sum of products, you will be getting this. Similarly, simplified expression of X is A plus BCD. Like this, we can simplify the 4 output functions Wx, actually it should be Y, Wx, Y and Z. Now if you see the Z, how many product terms are there? There are 4 product terms. Now this can be rearranged like W plus these 2 product terms. What is W? A, B, C bar, A bar, B bar, C, D bar. So which is again repeating here, right? So these 2 product terms can be replaced with W. So This particular output W would be acting as an input to realize the function Z. Right? So what is the first step you have to do in designing a PAL? If the question is asked like this, you have to simplify this using K-maps. So why we are simplifying using K-maps? To reduce the number of literals in a product terms. If you are reducing the number of literals, what happens? We will be seeing later. Right? So this is the first step you have to do. Now, that is what Z has 4 product terms, previously I have shown, and we can replace by W with 2 product terms. This will reduce the number of terms for Z from 4 to 3. So this is how we reduce the number of terms. And same PAL programming table can be represented like this, right? So the first product term, that is, what is the first product term? A, B, C bar, which can be represented like this. If it is uncomplemented, write 1. If it is a complemented, put 0. If the literals are missing, like D and W are missing in the first product term, so put a dash mark if the literal is missing. Now in the second product term, this is the second product term I am assuming, right? So if it is a complemented, A bar, B bar means 0, 0, C is not complemented, so 1, and D is 0, and W is missing here, so put a dash mark. Like this, you can represent the product terms, and the third product term is missing in the W, so put the dash mark. Right? So maximum product terms are 3. Maximum product terms are 3. W, this one, and this. So here W is having only 2 product terms, so there would not be any third product term. X is having 2 product terms, there would not be any third product terms. Anyways, W is having 3 product terms, Z is also having 3 product terms. So maximum every function has 3 product terms. So that's why we have taken maximum of 3 product terms. So to realize the first function, we require only 2 product terms. Indicate that. Similarly, to realize the second one, X, we require only 2 product terms. So X is equal to A, simply A, and B, C, D, W is missing. So put a dash mark, plus B, C, D means B, C, D equal to 1 because all are uncomplemented. Remaining are missing, that is A and W is missing, so put a dash mark. So this is how we can represent the same function using a table. That table is referred as a PAL programming table. It is very simple, right? And if you consider Z, W is there, so put a 1, remaining all dash marks. Right? So this is what the programming PAL programming table. Now coming to the final circuit of PAL with fuses. As I said, AND gates are programmable, right? What is the first product term? A, B, and C bar, right? So these are the inputs with a uncomplemented and complemented. So A and A bar, B and B bar, C and C bar, D, D bar, W, W bar would be indicated with the vertical lines, right? And the horizontal line is indicating with a product term. What is the first product term? A, B, C bar. Second product term, A bar, B bar, C, D bar. And the third product term is not there in the table, right? If you see the previous, there is no, nothing is there in the third product. There are no connections. So only the first product terms. So product terms are indicated with horizontal lines and complemented and complemented inputs with the vertical lines. So simply put a cross mark if there is a letter. Right? That means what we are giving to this AND gate? A dot B dot C bar. And what we are giving to this AND gate? A bar dot B bar dot C dot D bar. And this AND gate is not required because nothing is there. There are only two product terms for W. So that's why we can eliminate this AND gate by simplifying the functions using K-maps. This is an advantage of simplification. Right? You can also realize from the direct functions, but there are disadvantages. You require more number of AND gates. So to reduce the number of AND gates, we are simplifying using K-maps. And this is a NOT gate, right? So how to get A? A is directly passed through a buffer, and if there is a bubble, A is complemented. So this is how we'll be getting A and A bar, B and B bar, similarly C and C bar, D and D bar, W and W bar. How do you get W and W bar? This output is fed back to get W and W bar. Okay. So this is how you can realize all the functions, similarly X, Y and Z. So as I said, the important attribute of PAL is you can share this output to get the sum of the other outputs. So here Z requires W according to the table, right? Z requires a W. So how to get this W? That's why we are taking back W as an input, and this W is connected, right? For getting the Z output. Similarly, the other term for Z is A, C bar, D bar, right? Similarly, the third term is A bar, B bar, C bar and D, right? According to the table, right? So this is what. So whatever the input is required, you put a cross mark. So this is all the final circuit of a PAL, where simply programmable AND gate connections means there would be a single line. Wherever the connection is required, you put a tick mark, and what is that corresponding letter. So what are the things you have to remember regarding PAL? Means this is an original function that could be given. Simplify using K-maps. Why we are simplifying? To reduce the number of AND gates, to reduce the complexity of the circuit, to reduce the number of literals in each product term. Right? So once you simplify, you just trace whether any other outputs can be replaced in some other functions. In this example, W replaces the two products, which reduces the complexity. Right? So now prepare a table. What are the maximum product terms? 3. So if there is a literal, uncomplemented literal, you indicate with 1. If there is complemented, you indicate with 0. If the letter is not present, you indicate with the dash mark. And finally, put a cross mark wherever there is a letter in the corresponding product. You will be getting final circuit of a PAL. And the questioning is in different ways. The questions can be asked like this: realize the following function. Min terms can be given, or directly there may be chance of giving realize direct functions using this format. The third way is they can be given direct table and realize a PAL. This is one of the other way of questioning. So 3 different questions, answer is same. So feel free to ask your queries if any. Thank you.